Welcome to episode 46 of Fresh Thinking by Snowden Optiro. My name's Rayleen Hargreaves. I'm Principal Consultant and Reconcilor Product Owner at Snowden Optiro. Today, I'm joined by Ian Glacken, who is an Executive Consultant with Snowden Optiro. Ian is a mine and resource geologist with many years of experience over a range of production environments and commodities. As well as presenting Snowden Optiro's one-day reconciliation training course, Ian has carried out lots of reconciliation reviews and studies and sees the best and perhaps the worst of reconciliation. The topic of this podcast is reconciliation and moisture. Are we doing the right thing? Good to see you again, Ian.
Thanks, Rayleen. Good to chat. Looking forward to a discussion.
Let's kick off with why is moisture or contained water important in reconciliation?
Well, hopefully it's obvious, but you wouldn't think so from the lack of attention that it gets. But moisture, of course, is not necessarily the moisture that's contained in the minerals, but it's the water that comes along with the broken material. So if we have a very wet underground mine, when we load into the trucks, we're putting in quite a bit of water. If we put the material on the stockpile, the mine or at the ROM pad, and we have a downpour, then it all gets very wet. If we have a lot of clay-rich material, and if we're in the winter, then it's quite wet. So simply the fact that the moisture is quite variable, the production scenarios are quite variable, means that we need to consider it. The other point, which is the key point, which of course is extremely obvious, is that when we're reconciling against back in the mine value chain, so our mineral resource models, or reserve models, our mineral resource models, of course, the assays that go into those models are dry, and the tons are dry, unless it's a very special case where they've applied a wet density to the material. And there's a few commodities like that, but by far the vast majority of commodities, the block models are dry. So we're starting off with a dry product. We're breaking it up, we're fragmenting it, we're mining it, trucking it, and it's wet. So, you know, it's sort of, to me, it should be very obvious that we need to compare apples and apples. In other words, we need to compare dry tons throughout the mine value chain once they're broken and treated with the dry tons that we get at the start in the resource and reserve models.
So true. And I think if I think back to what we deal with, we talk about tons all the time, but you know, I think 2022, we need to be talking about, are you talking about wet tons or are you talking about dry tons at all stages, just so that we get rid of that ambiguity of tons and the assumption that everybody knows we're looking at dry tons or everybody knows we're looking at wet tons. I think, and obviously that moisture value plays a part in that calculation. So Ian, do you think there's a reason why some organisations are downplaying or even ignoring the impacts and the effects of moisture in their mine value chain?
Yes, I do. I think there's a few reasons. I think one of the main reasons is that logistically it's quite difficult to consistently measure for moisture, whether it's in an open pit situation where you've got a large shovel or a loader filling a truck, and in an underground operation where it's very tight, it's very noisy, it's very dangerous, and you have to stop the production and go and take a moisture. I think that's logistically quite difficult. It interrupts the production process, and you've got to take moisture measurements on a regular basis until you've got an idea of the pattern of the moisture. So I think logistics is one reason. And I think another reason, you and I are recording this in Western Australia, where it's winter now, but it's generally very hot and very dry. And it's all too easy to say, well, we don't have any moisture. Well, the fact is that even if you've got the driest mine in the world, you've still got inherent moisture, maybe 1 or 2%. And I would make the point that if your reconciliation's out by 2%, just because you're not correcting for moisture, that's quite significant. It's not going to make a bad reconciliation good, but it certainly might get you in the right direction. So yes, I think logistics, pressure of production, are the reasons why mines don't do it. What do you think? I mean, what are your experiences, Rayleen, when you're doing your Reconcilor studies with the ways that mines actually treat moisture in their system?
I think we see the broad range. So we see the fixed factor, that moisture just being applied across the board. We get the individual moistures against every material movement and in the plant, and then we ask for a moisture and it's not being recorded anywhere. Because it's so important, to be able to track that dry tons, wet tons comparison, and it does have an impact on reconciliation, we do insist on a moisture content. So whether that is a default and it is a factor that's applied across the board, or whether it's a moisture factor that's applied for perhaps just the mining component and then another factor that's applied to the plant, all variations of, we can actually bring that in, but we must have a moisture content for all aspects of the data for Reconcilor to work. And like I said, we're definitely getting that wide range across the board from the none to the on every movement. And so obviously if it's being measured, we want to have that measure come in. Could we not just take the moisture measurement at the plant? So after the primary crusher or on the mill feed conveyor, wouldn't that just work?
Yes, that's quite an appealing solution, because what happens inevitably and invariably, the metallurgists do need to know their process moisture, and they're much more rigorous and disciplined when it comes to taking a moisture measurement. Either they stop the belt, let's say it's the feeder from the cone, the crushed ore stockpile, to the ball mill. They stop the belt and they take a sample, and they're very good at taking moisture. Or sometimes they take it from the primary crusher. The problem with that is that the particle size of the material is quite large. So yes, it is very tempting for the mine to say, oh, okay, let's get the moistures from the mets. Problem with that is that, and it particularly happens at the crusher, and if it's particularly dusty, and apart from when it's particularly wet or wintry, most of the time there's quite a lot of dust generated as the material goes into the primary crusher. So they typically add water to dampen that down. Of course, that's an OHS thing. So obviously, when the material comes off the primary crusher, it's wet. It's wetter than it was going in. So that's one reason why the mine shouldn't necessarily be taking the moisture from the plant. And the same thing may happen when the cone is being drawn down. And so the conditions on the cone, which of course is not being drawn down at the same time as the materials being delivered to the crusher, means that moisture measurements might be quite different. So that's two good reasons why you shouldn't necessarily use the metallurgical moisture. I would say it's better than nothing. If you don't have any mine moistures for whatever reason, and you don't have any idea what they are, it's probably better than nothing. But I think it's a bit dangerous to necessarily assume that the moisture measurements on the tons, which might be going through maybe 12 or 18 hours after they've actually been mined or put on the stockpile, I think it's not necessarily correct to assume that they relate to the mine moisture.
Mm-hmm. And so how can we actually get a better or get a mine moisture?
Yep, good question. We mentioned that it's logistically quite difficult. There's a couple of strategies. And one of them, of course, is actually stopping the production process and taking some measurements. Now, they depending on where you're taking them, they need to be quite large samples, maybe 20 kilos or 10 kilos. And so the samples need to be taken and put in a plastic bag and sealed as quickly as possible. The advantage of that is that once the sample is being taken and put in the bag, even if it's quite a warm day and the moisture evaporates, it's still in the bag. So when you take that sample to the lab, you weigh it, bag and all, and then you do the drying as you would do normally for a sample, and that gives you then a dry weight, and then you've got the moisture. And obviously you need to correct for the weight of the bag, which is a few grams, and the weight of any ties. So that is a technique that is admittedly interrupts the process, but it is necessary. And another approach is to take a series of sort of orientation samples throughout the year. So in the winter, in the summer, and so on, and then develop a moisture profile. In other words, in Australia, we're in the winter now, so you might say in June, July, your moisture might be 3% or 4%. In February, March, it might be 1 to 2%. So in other words, you develop a moisture profile, and then that is something that you can apply to your mine tons. Obviously, that excludes the possibility of a 5-year or a 10-year rain event, and your material gets very wet. And obviously, in those cases, you might need to make a special addition. So there's a couple of strategies there. One involves interrupting the production process, and the other one involves taking samples maybe away from the production process, but developing some sort of seasonal moisture profile.
Yeah, always a tough one, isn't it, to get moisture predictions in when you don't necessarily know there's going to be a cyclone approaching in WA. I'm talking about. Talking about the reconciliation workflow, how should we handle moisture across that workflow?
Well, I think, as I probably mentioned earlier on, I think we need to eliminate it as soon as possible. I always advise people to correct for moisture as early as possible, and certainly in Reconcilor, that's what you have. The longer you carry moisture along in the system, the more chances there are that it gets forgotten about or not corrected at the right place. As a bit of a case study, we did some work at a company about 3 or 4 years ago where they had 5 or 6 mines feeding a plant, and some of these mines were 20-30 kilometers away. Some of them were underground mines, some of them were open pits, and the treatment of moisture was extremely variable from a fixed percentage, which was reduced from sampling all the road trains that went to the central plant, to doing nothing. And when the reconciliation calculation was being done, you had three different scenarios. So that's the sort of an example of how bad it can get. So I'm not saying that fixing the moisture or correcting for moisture is going to be the panacea. Obviously, when we're doing reconciliation, as you well know, we need to look at all of the physical measurements, and those physical measurements are moisture, in situ density of the material, the broken rock density, the tons, and of course the grade. And the reconciliation process it's all about getting those correct, but I would say that if we can make a start, if we appreciate that the water content is, let's say it's a minimum of 2%, and we subtract that or correct for that as early as possible, then we're on the way to fixing up one of those main physical issues. Then we need to work on the other ones, like the loose rock density, which is the subject of another discussion at some times. So my prescription, if you like, is quite simply to correct for moisture as early as possible, and that typically means that when the material is loaded into the trucks.
Yeah, I agree. There are so many contributing factors to to getting your reconciliation right, and I do see moisture as being the poor cousin to all of those other factors, those other physical factors that you mentioned just now. Look, Ian, that draws this podcast to a close. I would like to thank you for joining us on Fresh Thinking and for participating in this discussion on moisture. I think it's a really hot topic, and it needs probably a lot more thought from a lot of people out there, just to see how they can get those moisture values sort of updated throughout that mine value chain and incorporated into their reconciliation process.
Thanks, Rayleen. I think if we've made people at least think about that moisture as it is an issue, then maybe we've done something for them. So thank you very much.
If you'd like to listen to more of Fresh Thinking by Snowden Optiro podcasts, you will find them for free on our website, on Spotify, YouTube, Stitcher, Apple Podcasts, Google Podcasts, and most other podcast platforms. Thank you.